Right, folks. So the plan is to spend maybe 20 minutes or so just reflecting on many of the topics we discussed today in this workshop. And this is the panel discussion on 3D scene understanding. I'm going to moderate the discussion. And as Jen mentioned, Manolis is here, Elisa you have already met, and Federico is also joining the panel. So more than me throwing questions at the speakers, I would like for you to interact and to ask the questions, burning questions that you might have. So I'm planning maybe to ask a couple of questions, like just to kick off the discussion, and then open it up, like for you to ask more. Okay. We start actually with pretty obvious, fundamental question, which is. Which has been hinted to already, the last question from the audience. Elisa already, gave her answer to that. Essentially, when we're doing 3D scene understanding, it's clear that foundation models are going to play a role. And I wanted to hear from our speakers about, what is the role of these foundation models for scene understanding? In particular, if you're thinking about language, in which way can we use language to speed up, or to improve our quality of scene understanding? And Manolis, if you don't mind, we'll put you on the spot and see if you have thoughts, and we'll just go around the room and pick the brains from the others.
Sure, happy to kick things off. Maybe I'm not the most qualified to talk about language, but I will attempt. So I think language, right, we use it to communicate. People use it to communicate. So I think it's a very useful modality to tell us what's important for people, right? What are the important aspects of a scene, right? What's salient for people to communicate about? And so I think in some ways, these foundation models, we can, extract from them a lot of information about, the objects that can be present in a scene that may be important to talk about, to communicate about, and what's salient essentially in different kinds of scenarios, right? So when people talk about a scene, they probably mention specific scenes, specific objects in particular, contexts. So this aspect of, what's salient for communicating, right, between people, I think is captured well by language. And it can also be, I think, a good way to allow people to, somehow specify, or to, tell us, what is in a scene, right? Or how should a scene look, right? So anything that has to do with, communication with people, probably there's a big role that language will have. It's also, maybe to touch a little bit more on this latter point, I think it's a very useful way to alleviate maybe the content bottleneck that we have for 3D scene representations. There's, like digital representations of the world, we don't have that many of them, and allowing people to somehow, specify for us how a 3D scene should look by using language as input, maybe is a way to scale, right? To make it, much more broadly accessible, to design, 3D representations. So yeah, maybe that's the thing that comes to mind.
It's a great perspective, actually, thinking about language as a way to tell the robot, what to perceive in a sense, to guide, the attention of the robot. I think is a very interesting take. I will move on and ask Federico maybe if he has thoughts. Federico, if you want, you can discuss both opportunities but also challenges. If you see language as being problematic for some aspect of perception, I'm very curious to hear your thoughts.
Yeah, first of all, I'm sorry not to be there with you in person today, but I've heard, let's say, the workshop has been extremely well and interesting so far. So also congrats to speakers and organizers. In terms of these, let's say, question around foundation and language models, there's been like huge number of papers emerging in general research activity in this area that basically affects both computer vision, machine learning, and robotics community altogether. To me, I fully agree with what Manolis mentions about the importance of using language as a way to capture, for example, attention or saliency. to me, one interesting aspect, which also relates more to certain, let's say, directions now emerging also in the machine learning community, is mostly to see language and text as a, let's say, possibly a universal or common interface for different types of models that could also be more specialized models. For example, ML models that are focused or training to just do a very small and very specific task with a very high accuracy. And also, let's say, other types of actuators or embodiments of AI that are typically not suited to communicate with for example, with models that rely on a server or large database, typically also a robot, right? So the idea of using language and text as a universal way to interface a lot of different components is quite interesting and exciting from my point of view. I was part of a collaboration recently that ended up with a paper that was called Socratic Models, where the idea was to a little bit explore this aspect of using together visual language models, specialized computer vision models, other types of models, for example, based on audio, all interface together through LLMs. So LLMs, basically, they just take the task of asking questions, getting back answers, and then broadcasting answers to the different components. There's another work still related to, let's say, this area, and that was also quite exciting to see, which is Palmi, also from Google Research mostly, where the idea is also towards this possibility of using embodied AI with multimodal models. In a way, the question that we want to ask ourselves is, can a robot, let's say, ask questions and use an LLM like, I don't know, ChatGPT or Bard to answer questions about the scene, and which language or which way of interacting with the conversational model is the best? And text and language is maybe what comes to mind as a first answer.
Great, thanks, Federico. Elisa, I know you already mentioned, like, gave your answer to the language model questions. I was still wondering, like, if you want to add more. Otherwise, we'll move to the next question.
No, I think it's fine.
Okay, good. Okay, so great inputs, I would say. Like, I want to now ask a question which I end up thinking a lot about. Many of the people in this room, like, are doing maybe some sort of 3D mapping, and I've been doing some sort of 3D mapping, and some others will be doing reinforcement learning maybe, and have the robot, figure out the right representation for a task and so on. I wanted to hear from this panel and ask, a question about explicit versus implicit representation. Explicit representation would be just a 3D map. Implicit would be the implicit representation, maybe that reinforcement learning is forming. The question is, do we need explicit representations? Like, is that something that you envision needing, like, for the future of robotics? Or do you think that eventually explicit stuff will disappear just because implicit representation will be more efficient, will be, like, more powerful? And I don't want to put Manolis on the spot this time. Let's see if any of you, like, wants to get started. Otherwise, I'll put Manolis on the spot. Any takers?
I can share some thoughts, maybe just to initiate the conversation. So that's actually a question that we are asking ourselves quite frequently these days, in the sense that explicit representations for the purpose of 3D mapping provide very complementary characteristics. At the same time, it's currently hard to fill the gap between the two, in the sense that implicit representation give you this fantastic, let's say, high quality, viewpoint dependent way of capturing, for example, appearance characteristics of the scene, which is something that typically you lose, at least to the fine details, with the explicit ones. But they do have this major problem of requiring extremely good poses, extremely good, let's say, image quality, but especially being extremely slow at both training and rendering. So that if you want, for example, render 3D maps or train 3D maps, which is an extremely important characteristic for SLAM and 3D reconstruction for robotic perception purposes, right? this is something that's really, really hard at the moment. And with a traditional explicit representation that you can obtain through volumetric mapping, TSDFs, circles, and so on, you kind of get the other pros and cons, right? So finding a way to actually merge these two and use them together, I think is actually quite a challenge, but it's one of the things that we will have to do as a community in the next few months or couple of years.
Great, thanks, Federico. Isa Manolis?
Yeah, I can add. I can add maybe a thought. I think I would agree with the points that Federico raised just now. There's pros and cons, and some combination of these explicit and implicit representation is probably the thing that will get us farther forward than one in isolation. But maybe one specific point about explicit representations. These more traditional 3D maps, explicit representations of geometry and such, they emerged because for people, right? As people, essentially, we can understand, right, what an environment is if we view it as here's the explicit representation of the environment, or here's the 3D map, right? We can view it. So it's important, I think, to have an explicit representation whenever there's this need to communicate some information to the person, right? If there's a human and they need to somehow, interact with the system that's doing something, say in a 3D scene, then having at least the relevant part of the 3D scene be made visible to the person explicitly and communicate with respect to that helps us ground, this understanding of what we're talking about. So that, I think, is maybe a big pro that explicit representations have. So whenever we need to, have this communication with a human, or allow the human maybe to do something, right? To specify, okay, this point, right? Go there, right? Or, don't go there, or, this object, that's where I think explicit is really important. But maybe we don't need to have everything be explicit all the time, right? So there's maybe a small region, right, that's important to communicate about at a particular, point. So the rest maybe can be left more implicit, while while we only care about a particular region. So yeah, that's maybe the thought that I would add.
If I can add on top of that, there is also a trade-off in terms of maybe sample efficiency. I'm thinking about reinforcement learning. If you have to do the reinforcement learning from scratch, like pixel to action, you will need many samples, like many trials, because you will need to figure out the perception part. The internal representation, we'll have to figure it out from pixels. Instead, I think there are a bunch of papers in which if you feed to the reinforcement learning some intermediate representation, call it maps, or call it some intermediate representation, you can get way more sample efficiency, because the reinforcement learning will focus on the control part of the task rather than the perception one. Elisa?
Yes, so I would like to, so I also agree with Federico and Manolis and you, so everybody mentioned, makes sense to me. I would like to add that I want to see it as a point of view of compression or representing your data effectively, first of all. And I think a 3D map, okay, it will be there. It's easy for us to interpret, to navigate. We live in a 3D world, and we have a lifetime experience of doing this task in an explicit representation, but maybe we are still figuring it out for implicit representations. But on the other hand, this 3D map will be noisy. This will be consuming a lot of space for large scenes. So I would think of in the direction of using implicit representations to circumvent this these points. For example, instead of having a very noisy chair there with missing legs in a real world reconstruction, you can just simply identify that, okay, I have a chair there, and you can very efficiently put a chair that is maybe not exactly the same one if it's just there as a placeholder and you're not planning to do something particular with it. So this is one thing that I think certain parts of this explicit representation, which I think eventually will be needed, should be to replace certain components of it to make it a bit more efficient. And the second aspect is what Federico mentioned about implicit methods being good at giving you a more reliable, view-dependent visual output. And I think this is also something that I might have seen in my work. So I think that visual information is basically more effective in 2D. We have images, if we have images with high quality and so on. So maybe a combination of reasoning visually on 2D for what we see and what we understand, and maybe even doing segmentation there and trying to fuse it later. While in 3D, we rely more on geometric based tasks and have this basically for navigation without ambiguity or where we are or so on. So yeah, I think these two aspects is where explicit might have a bit of drawback, and we can try to call implicit representations to kind of help with certain things there.
Perfect. Thanks, Elisa. So we're running out of time. I think it's important just to hear, from the room and see if there are questions. Any point that you want to raise for the panel? So let's open it up and let's see.
Just a quick question for the panel. So scene understanding in this context also means making the scene relevant for motion planning. And one of the key components of motion planning is collision avoidance. And collision avoidance for robots don't really require 1080p images or something like that. What it requires is the relevant amount of data that is useful for the robot to just avoid local obstacles. Explicit representations have been pretty beneficial historically. What do you think we can do further in terms of improving scene understanding for navigation? There is obviously a question about go fetch this object and so forth, but I'm just talking about moving the robots fast in an environment. Can we do even better from the current state of art and stuff like that?
So if I can rephrase the question, maybe do we even need 3D scene understanding for obstacle avoidance, or are there opportunities maybe using scene graphs, implicit model, explicit models to improve fast obstacle avoidance?
I can give an example, like a motivating example. Let's say there's a robot that is flying, but it can't fly over a river because it might lose features, it doesn't have GPS, right? So it needs to know that there is a river in front of it. And that requires some amount of understanding. But at the same time, you don't need a lot of fidelity to represent a river in the memory of the robot or something. It can probably be represented with a few voxels. So how do you balance explicit representations and the requirement to encode semantic knowledge in the map?
Yeah, maybe one quick thought there. I really liked Rajat's talk earlier today, right? 3D scene graphs that have some level of semantics encoded in them. It's a pretty useful tool. I don't think we need to, have high fidelity appearance information for all the regions of an environment, even if we're trying to explicitly represent what's going on. Capturing important things that are important to the task, like, okay, we're over a river here, or, this is the material of this surface, right? So you shouldn't go fast here, right? You're in danger of falling over if you try to, move very fast on a slippery surface or something like that. Yeah, so encoding that as a semantic, kind of label that's relevant to the task, I think is probably the way to go. and I believe that's maybe what you're thinking when you're asking, can we how can we do better? What's a challenge for efficient and safe navigation, right? So yeah, that's my quick reaction to that.
Maybe if I can echo what you said, and also like the comment you had before, maybe you can imagine the instruction for the robot being specified in natural language, like go, but avoid the river and so on, and this natural language somehow directly impacting the labels that you have to put in the scene graph. Maybe there's the connection that you mentioned earlier about the large language models. Federico, Elisa?
I can share some thoughts. I think this is a very good example of, let's say, a case where you have like a robotic agent and you don't really need a lot of, let's say, detailed information about your scene. But just to, let's say, stick to the example of drones, drones flying in open environments, very frequently, they also need to face a lot of other obstacles. And if you just think about very common obstacles you might find in other environments, such as, for example, trees, that's where you start having like thin branches, leaves. That's where you start to have like the need to detail much better, for example, the level of detail of your obstacles and the representation of your team, because especially if you're like in the woods and you need to fly through tree branches or across or just avoid them. The same thing happens, since you mentioned also path planning and not just obstacle avoidance. If you're in indoor environments, back at Willow Garage, we used to have this task in mind as a milestone, which was picking up beers, right, from the fridge. Or similarly, just pick let's say, for example, little objects or open up doors. That's where you need to really have a lot of very fine-grained semantics. And sometimes geometry is also not sufficient. Like, for example, picking up a specific product and distinguish it from others. That's where you need, for example, fine-grained appearance. And so clearly, if you have specific cases in mind, like the one you mentioned about the river, of course, that's where you need to specialize your robotic application to avoid using a lot of, let's say, semantics and scene understanding. And that's actually what you need to do, because if you need to fly a drone, you also need to save up a lot of memory and computation, actually as much as possible for everything else that you need to run your drone. At the same time, there's still plenty of examples where actually current methods for scene understanding and scene representations in particular are actually not sufficient to provide the level of details for the path planner and for example, also object manipulation. So I think in that sense, the effort that we need to put in place for providing better representations, better trade-offs, is still very open as a challenge. Elisa, I don't know if you want to add anything on top of this.
No, I think I have nothing useful to add.
Right, thanks both for the comment. We have one more question.
Thanks for the very good panel discussion. And I have I'm a bit of confused by the definition of the explicit and implicit representation here. From the panel discussion, I take this implicit meaning the hidden state of the RL agents, this kind of stuff. But it's for the nerve, neural implicit rendering stuff, they also call it implicit representation of the thing. And you can get very good geometric properties from the nerve models, and they can also provide you with very good user human robot interaction, these kind of features. Yeah. So is it maybe there could be some representation, so we can combine the benefits of both the explicit and implicit merits this kind of stuff in the future with the nerve-like stuff.
Yeah, maybe I can make a quick comment on this, being the graphics guy here. So there's different terminology for this, right? So in the computer graphics literature, explicit versus implicit has a slightly different meaning. Explicit representations of geometry are ones that explicitly define the surface, whereas implicit ones are where the surface is implicitly defined by a function, right? So you can query that function and know are you on the surface or you're some distance away from the surface. So that's that interpretation is maybe what you were hinting at, right? Where neural radiance fields, you have a volume essentially, and you have some densities in that volume, radiances, things like that. Implicitly, there's some geometry in there, right? That's the notion of implicit. So it's a little bit different, I think, than the implicit here, where we're talking about a representation of the environment, of the geometry of the environment that maybe an agent has learned. Yeah, so that was just a quick comment.
Yeah, hard to say, like, the boundaries are really, like, I agree with your definition, and maybe neural, maybe is a better term for implicit here, because, it's neural networks versus traditional. What do you guys think online? Like, what's the definition, or like, what's your interpretation of explicit versus implicit? Is NERF an implicit representation?
I would call it like implicit, given that it's a representation that is learned through typically an NMLP, right? At the same time, the consideration that some of the considerations that we raised beforehand are still valid. For example, now there's actually a quite interesting direction in the literature around using NERF with SLAM, but it's still very, very open, very challenging because of these efficiency-related limitations. If you want to use NERF to represent your environment, right, you need to be able to train one or multiple NERFs very, very quickly, and then to be able to render this or to extract geometry out of this. And this is a process that requires, it's very much offline at the moment. It's really hard to train one or more NERFs from an environment on the fly. There's a few works that came out recently that go into this direction, but we're still very far away. And that's where I see also the gap that we need to fill. Extracting geometry is also quite challenging in terms of memory and time. So it's a promising direction, but there's still a few gaps that we need to fill.
Okay, unless there is more from Elisa, like, we can, do we have time for one last question?
I think so.
Okay.
Hi. So I just have a rather open-ended question to ask. I'm just wondering how you think we should represent affordances, and what you think is the way forward on that. Yeah. Also, like, should it be an explicit, implicit thing, or what you think is the way forward on that? Yeah.
Beautiful question. Yeah. And then to be honest, I think that everybody, like, with 3D scene graphs have that kind of question on their mind. So important. Any ticker?
Yeah, affordances. Maybe just a quick thought on that. If we take Gibson's, definition of affordances as being something that is about a specific agent in a specific environment, the actions that that environment affords the agent, then I think those are the two important ingredients, right? The environment, the structure of the environment, and then the agent, the embodiment and how it can act in that environment. So it's pretty natural to me to think of, explicit representations when we talk about that, because those capture, the actual structure of the environment and the structure of the agent. But how do we, learn, those explicit representations? Maybe there's something, that's happening somewhere that is implicit, and we produce a representation that is more explicit.
Just to clarify, like, the previous doubt, in this case, explicit means that you have, for example, a series of objects, and to each object you attach some affordances.
Right. Yeah, that's right. Yeah.
And implicit instead is maybe about learning those properties through interaction, that kind of thing?
Correct, yeah.
Okay. I will pass it to Elisa or Federico.
So maybe one aspect which I consider relevant in this case is figuring out, because, okay, affordance is a property of a certain object, like you can sit on a chair, but if it's a folding chair, you cannot always sit on it, like if it's in a closed position, or you cannot open a door that is already fully opened. So I think there should be some temporal component to it. There should be a way of identifying if, okay, this affordance is there with this object, but it's also, this can change depending on the state of this certain object. So I guess maybe having the agent learn all these things is one way to go, because you would say that, okay, you learn from experience basically that you cannot do a certain action with a certain object given a certain state, and maybe learning this from experience, maybe combined a bit with a few priors of external explicit human knowledge, it's maybe something along those lines is the way to go.
Great comment. Okay, Federico, any other thoughts?
Maybe I can just add like a small direction that I find particularly exciting, which is the one around open set learning and open set segmentation. In particular, the idea that, so part of the scene understanding community is going towards the use of pre-trained embeddings from CLIP or many others, for example, ways to pre-train your own, let's say, embedding from a VLM or other models, to expand the labels of a semantic segmentation that you can run on a scene from a closed set, which is your training set, to an open set, which is all the classes that, for example, the VLM has seen during training. This is quite interesting, and I think it has a very direct connection also to affordances, in the sense that it seems that once you're able to use these embeddings for open set segmentation, you're not just able to label things such as, for example, I don't know, bowls, cups, cabinets, shelves, but also related to actions. So an area where you can relax, an area where you can cook something, and also material properties, but also affordances. So if you go, for example, door handle or open window, so you can practically specify a lot of components, and the embedding seems to react quite well to this type of text-based affordance-like kind of like label. So this is quite an exciting direction that I think is definitely worth exploring more for the community as a way to extract more naturally, in a kind of zero-shot way, affordances from our environments.
So in a sense, paraphrasing what you're saying, Federico, like, you know, also for affordances, there is a role maybe for language models to have that kind of knowledge, like, you know, and to access that kind of knowledge directly without supervision. Is that what you were hinting to?
I mean, in this case, the embeddings are somehow generated typically through VLMs, right? So visual language models, where you kind of pair together a text embedding and a visual embedding. But the nice thing is, yes, you can specify your kind of affordance through text again, and let it basically get a good match through this kind of like joint embedding. Again, in this case, you know, we all know that affordances are relatively abstract and hard to define concept, right? So we know what we mean by affordances, but it's sometimes hard to explain and hard to put it into practice. And especially hard to teach a robot what an affordance is. And so again, maybe text and natural language could be a way to do it more naturally. Also because, again, if you're a robot and you need to talk to a large language model, you need to get information from the internet or from a server or from a large database, how would you do that? Probably, again, natural language is the way to go.
I think that's a great way, probably, like, you know, to close the panel. We started with foundation models and language models, and we're closing the loop and going back to language models, which tells a lot, actually, about you know, the perception and importance of these topics. So yeah, let's close just here, and let's thank the panelists for this great discussion. Thank you guys so much.